dear students, St. Joseph's College for Women Autonomous Vishakhapatnam. Welcome to St. Joseph's Open Web-based learning platform. So, e-learn for a joyful and enriching e-learning experience. Department of Chemistry presents more St. Joseph's massive open online course, Pharmaceutical and Medicinal Chemistry, a modular skill elective course. I'm Dr. L. Chinnari, lecturer in chemistry, St. Joseph's College for Women Autonomous, Vishakhapatnam. Pharmaceutical and medicinal chemistry, module 3 is chemotherapeutic drugs, chapter 3.4 is macrolide antibiotics. By the end of this chapter, learner would be able to classify antibiotic drugs, including macrolides, depict the structure of erythromycin, enlist its silent features, and comprehend the mode of action, pharmacokinetics, indications, and contraindications of erythromycin. So these are the contents of this chapter: classification, introduction, classification of antibiotics, introduction, classification of macrolides, classification of erythromycin, structure and silent features of erythromycin, mode of action, pharmacokinetics, and uses, adverse drug reactions, indications and contraindications, interactions, etc. So we discussed already in the last chapter uh, classification of antibiotics based on the chemical structure: aminoglycosides, cephalosporins, tetracyclines, penicillins, sulfonamides, fluoroquinolines, macrolides, carbapenems, lincosamides, glycopeptides. So in this chapter, we are discussing about macrolides. So coming to the introduction to macrolides, macrolides are a class of antibiotics derived from Streptomyces erythrea, also called Saccharopolyspora erythrea, a type of soil-borne bacteria. Macrolides are macrocyclic lactone ring molecules. They belong to the class of polyketide of natural products. The first identified macrolide is picromycin in the year 1950. The second identified macrolides are erythromycin and carbomycin in the year 1952. Some macrolides are identified from the soil samples. Example one is spiramycin, second is josamycin, third one is rosamycin. These macrolides are clinically inferior than erythromycin and its derivatives. So this is the general structure for macrolide. So the macrolide having the D-desosamine and L-cladinosine and macrocyclic lactone ring. So this is the macrocyclic lactone ring. This is the D-desosamine. This is L-cladinosine. So coming to the classification of macrolide antibiotics, and antibiotics of macrolides are classified as 12-membered ring, 14-membered ring, 15-membered ring, 16-membered ring, 17-membered ring. So coming to the 12-membered ring, examples are methamycin and neomycin. So 14-membered ring again classified into natural products and semi-synthetic compounds. Erythromycin, oligodomycin, sporiamycin are the examples for natural compounds. Roxithromycin, erythromycin, fluorithromycin, clarithromycin are the examples for semi-synthetic compounds. So coming to the 15-membered ring, azithromycin is example for 15-membered ring. So coming to the 16-membered ring, it is also again divided into natural compounds and semi-synthetic compounds. Spiramycin, josamycin, medicamycin, ketsamycin are the examples for natural compounds, and rocithamycin and miocamycin are examples for semi-synthetic compounds. So coming to the last category in the classification of macrolides, 17th membered ring, that is Lancashidine complex. So these are the microlides. Indicative examples are the erythromycin, clarithromycin, azithromycin. These are the structures of erythromycin, clarithromycin, and azithromycin. Macrolides are used to treat diseases caused by gram-positive bacteria. So coming to the structure of erythromycin, it is a macrolide antibiotic largely produced from Streptomycin erythris or Saccharopolysporia erythrea. It contains neutral and basic sugar units linked to the lactone ring. Macrolides equal to basic sugar unit plus neutral sugar unit linked to lactone ring. Erythromycin having desosamine plus erythronolide and cladinose. So this is the structure of erythromycin. So coming to the classification of erythromycin, so this is the structure of erythromycin. In this erythromycin, instead of this R1 and R2, if we substitute OH and CH3, it is erythromycin A. So if we substitute H and OCH3 instead of R1 and R2, it is erythromycin B. If we substitute R1 and R2 are OH groups, it is erythromycin C. If we substitute H and OH, one hydroxyl group and one hydrogen, instead of R1 and R2, it is erythromycin D. So this is the classification of erythromycin. So coming to the silent features of erythromycin, the life-saving activity of penicillin inspired scientists to discover new antibiotics. This resulted in the discovery of a new class of antibiotics called macrolide antibiotics. Possess the following features. They contain a large lactone ring and hence they are called as macrolide antibiotics. They contain many keto and hydroxyl groups. They contain not only neutral sugars but also amino sugars. These antibiotics are active against gram-positive bacteria. Their biological activity is similar to penicillin, but unlike penicillin, they are not destroyed by penicillinase enzyme. Hence, these macrolide antibiotics are used as substitutes to penicillins. So, coming to the mode of action, it destroys the bacteria of interfering with the synthesis of proteins by binding to the 50S ribosomal subunits. Its antimicrobial spectrum is similar to benzyl penicillin. Hence, it is used in penicillin allergic patients. So, this is the mechanism of action of erythromycin. So macrolides binds with 50S ribosomal subunits, bind with 23S RNA in the polypeptide exit tunnel and adjacent to peptidal transferase center in the 50S ribosomal subunit. Then it inhibits peptidal transferase activity, then interferes with translocation of amino acids during translocation and assembly of proteins, then finally inhibits protein synthesis. So coming to the pharmacokinetics, erythromycin is destroyed by gastric acid. Food interferes with absorption. It is available in the form of steroids and esters, and they are fairly acid stable. Its half-life is 1.5 hours. Large amount of drug is secreted in bile, excreted through feces. Only 5% of drug is excreted by kidney through urine. Those adjustment is not required in renal insufficiency patients. It enters into neutrophils and macrophages. This drug crosses placenta. So coming to the uses, diphtheria, chlamydia, pertussis, commonly acquired pneumonia, ear infections in children, dental abscesses, sexually transmitted infections. Adverse drug reactions are nausea, vomiting, diarrhea, increased GI distress, hypotensivity reactions like fever and rash, and torsade pointers, and infantile hypertrophic pyloric stenosis in infants. Coming to the indications, upper respiratory tract infections like flu, sinusitis, bronchitis, abscess, wounds, gonorrhea, whooping, cough, etc. So coming to the contraindications, macrolides are contraindicated in patients who have had an allergic reaction to them. Concomitant administration of macrolides with astamidrol, cisapride, pimozide, or terfenadine is contraindicated because potentially fatal cardiac arrhythmias may occur when clarithromycin or erythromycin is given with these drugs. This effect is most likely due to inhibition of metabolism of these drugs by erythromycin and clarithromycin. So, last point is the interactions. Macrolides should not be taken with colchicine as it may lead to colchicine toxicity. Symptoms of colchicine toxicity include gastrointestinal upset, fever, malaria, pantopinia, and organ failure. Thank you.